Well, hey everybody, how you doing? We're going to finish up and talking about SOHCAHTOA today and learning how to use trigonometry to solve right triangles. And we're actually going to do some applications, some word problems. Now I know what you're thinking, oh gosh, not word problems, but these really are not that bad. Okay, before we can begin the word problems, we got to learn some vocabulary. Our two words today are angle of elevation and angle of depression. And these are very easy words to understand. Think about what the word elevate means. Elevate means to go up. So an angle of elevation is an angle formed when you physically look up. So think about it, guys. Right now I'm looking level. If I pick my chin up, this angle here is called an angle of elevation because now I'm looking up at the ceiling. The angle of depression is just the opposite. Instead of looking up, an angle of depression means you're looking down. So again, I'm right now eye level, but if I drop my chin and look down at the ground, I've just made an angle here. So that's what we're going to be talking about today. So in trigonometry, this is your definition. An angle of elevation is you looking up. So I'm not the best artist in the world, don't giggle. Here I am, and I'm looking up at this object, whether it be a kite, maybe it's an airplane, maybe it's the moon, the stars. When I look up, the angle formed by the ground and your line of sight. This is your line of sight because I'm looking at that object. When I look up, this angle formed is called the angle of elevation. Just the opposite is if I was up in the sky, say in an airplane, and I wanted to look down at Bossier City, the angle formed by my line of sight and the sky, this right here is my angle of depression. Okay, so I just want to show you that really easy vocabulary. Elevate means the angle I form when I look up. Depression is the angle I form when I look down. Now what I want you to notice is if I drop a perpendicular here, the angle of elevation is inside my right triangle. And it will always be inside your right triangle when you're drawing your pictures for our application problems. So our angle of elevation will always be inside our right triangle. However, if I look at my angle of depression and I draw the ground here, the angle of depression may or may not be in my right triangle. If I drop a perpendicular here, then the angle of depression is not in my right triangle. Okay? Now, you're right. If I drop a perpendicular here, it would be. But 9 times out of 10 in our word problems, the angle of depression is not inside the right triangle we're working with. So you're going to say, well, if the angle of depression is not inside our right triangle, how are we going to use it? Well, here is a good concept to learn. If I am here in an airplane, so let me put myself in an airplane. Again, I'm not the best artist. And you are here on the ground waving at me, saying, hi. I'm looking down at you. So here's the sky, and here's my line of sight. That angle is called the angle of depression. Suppose I know when I measure that, that's 40 degrees. Okay? So the sky and my line of sight to look down at you, that angle formed is 40 degrees. Well, guys, if our eyes are to meet, when I look down at you, if you're to look up at me and our eyes are to meet, then our angles of elevation and depression should be equal. If you look here where you are here on the ground, you're on the ground and you're looking up at me. This angle here would be our angle of elevation. And if you know anything about geometry, the sky and the ground are parallel to each other. Correct? That means they should never meet. And if they're parallel, when you draw this line through them, which in geometry was called a transversal, you form special angle relationships. The angle of depression and the angle of elevation are equal in measure, because back in geometry they were called alternate, interior angles. I remember teaching geometry, we called those AIA angles. So you learned in geometry when you had two parallel lines, which is what the sky and the ground are. They're parallel, they'll never touch. If you draw a line in between them, cutting through them, which in geometry was called the transversal, you form angle relationships. And one of the angle relationships was called alternate interior angles. Why was it given that name? Because if you think, here are the two parallel lines, the sky and the ground. These two angles are inside of them, interior. They're alternate. They're on different sides of that line cutting through, alternate. Alternate interior angles are exactly the same measure. If I took out my protractor and measured this at 40 degrees, then this would be 40 degrees. So, the moral of the story is this. We're about to embark on doing some word problems. Every time they give you the angle of depression, put it in the picture also as the angle of elevation. Because if I'm going to look down at you, and my angle of depression is 40 degrees, and you're going to look back at me, and our eyes are going to meet, your angle of elevation has to be the exact same degrees. Okay? So let me get my notes now, because let me read you out. We're going to do two word problems together. Okay. In your notes, we're going to look at example 1. And the reason why I'm choosing this one is it doesn't have the picture already drawn. It says, the angle of elevation from the bottom of the world's longest slide, located in Peru, Vermont, is approximately 10 and 3/10 degrees. The slide has a vertical drop of 821 feet. Find the length of the slide to the nearest foot. So guys, when you go to do your homework assignments, there's going to be a word problem. They do not have to have the picture drawn for you, which means you're going to have to draw it out yourself. So let's draw a picture of what we're talking about. All right, so it says, the angle of elevation from the bottom of the world's longest slide. So let's stop right there. I would think all of you have knowledge of what a slide looks like. I'm sure all of you have been to the park and you know a slide goes diagonally. So there's stairs to a slide, and then there's the slide itself. So here's the slide. Okay, I think we all know that. There's a slide. And we know a slide is going to be perpendicular to the ground. Okay, so we know this picture is going to be a right triangle. Okay? It says the angle of elevation from the bottom of the world's longest slide. Well, the bottom of the slide would be here. The angle of elevation is the angle formed with the ground and the line of sight. So you must have just got off the slide, and here you are. And you're going to elevate, you're going to look up. This angle is 10 and 3/10 degrees. Make sense? The slide has a vertical drop. Vertical goes in what direction? Up and down. So that's what this is talking about. The vertical drop is 821 feet. Find the length of the slide to the nearest foot. So I want to find the length of the slide. Well, we know this is across from the 90-degree angle, so we're going to call this C. Okay? Makes sense, everybody? Or you can call it X, whatever you want to do. But we're going to call it C because we've been using A, B's, and C's for right triangles. Now, if you want, you can label the angles. You know this is angle C because it's 90 degrees. And that vertical and horizontal meets at a 90 degree. You want to call that A and that B, that's fine. You don't have to, but if you want to. So what we learned in the previous lesson is to find a missing side of a right triangle, we either could use geometry, Pythagorean theorem, or we can use trigonometry, SOHCAHTOA, which is our abbreviation for our trig functions. If you look, can we use Pythagorean theorem? No. We got side A, but we don't have side B, and we don't have side C. So Pythagorean theorem is out. So we have to rely on trigonometry. So I'm going to write up here SOHCAHTOA. We got to decide which trig function to use. You don't get to go eeny, meeny, miny, mo and pick which one you like better. That's not how it works. What we learned in the previous lesson is to decide on the trig function, you put your finger on the acute angle. Is 90 degrees an acute angle? No. So we're going to put our finger here. That's our acute angle. We're going to label two of the sides. We're going to label the side we know and the side we want to find. The side we know is 821 feet. And this relationship is they're opposite each other. So I'm going to write the word opposite. The side we want to find is side C. Well, you can't call that the adjacent. Even though it's next to this angle, that's acute, it's not the adjacent side because it's across from the 90 degrees, so we know that's the hypotenuse. So now we know we're going to use the trig function for opposite and hypotenuse, O and H, and it's right here. We're going to use sine. So we're going to set up sine theta. Remember, you don't ever write a trig function without an angle behind it. Equals opposite over hypotenuse. Once we get here, we're just going to fill in our equation with what we know. Sine, we know our angle is 10 3/10 degrees. We know our opposite side is 821 feet. And we know our hypotenuse is C. Everybody's good? We said when we set up these relationships, they're proportions. And to solve a proportion, you cross multiply. I always like to put my 1. When I cross multiply, I want my variable on the left. So I'm going to do C times the sine of 10 3/10 degrees equals 1 times 821 is 821. To solve for the hypotenuse C, I'm going to have to divide by sine of 10 3/10 degrees. So we would write C equals 821 divided by the sine of 10 3/10 degrees. But now you can't leave it like that. Because first of all, in the word problem, it said round to the nearest foot. So we got to get this as an actual number. So now we're going to go over, I'm going to walk over, we're going to get out our calculators. Okay? So listen to me. All right? It doesn't matter whether I use my Pro or my TI-30. What mode do we have to be in? That's right. We have to be in degree mode. So let's turn our calculators on and let's check. Well, the Pro is in degree mode. There it is, DEG. And the TI-30 is in degree mode. Good. How do we type this in? We type what we read. So we're going to type 821 divided by sine 10 decimal point 3 and close it. We don't need to put the degree symbol because we're already in degrees. And we'll hit equals and we'll get that lovely decimal. Now it says to round to the nearest foot. So I'm going to put my finger, the nearest foot, the digit's 1. Behind it's a 6. So if that's 6 or higher, this will go up to 2. It is important in a word problem to answer the question. So you should write in words, the length of the slide is. I know that's crazy for you to write in math, but that's what you should write. The length of the slide is 4,592 feet. And don't forget your units. See how easy that was? Everybody's okay? Great. Let's try one more in your notes where the picture's not given. So that would be word problem 4. Okay, so let's go look at word problem 4. Because I drew that picture in. It wasn't given. So let's explain where that picture's coming from. Okay. All right. So we're in our notes, we're at word problem 4. It says, a ranger's tower is located 44 meters from a tall tree. From the top of the tower, the angle of elevation to the top of the tree is 28 degrees. And the angle of depression to the base of the tree is 36 degrees. How tall is the tree to the nearest meter? Okay, so let's think about this. Now, I know I like to be cute in my notes, but I'm being serious. This is a real life word problem. Draw a picture. They're talking about we have a tree. All right? So I'm going to draw a tree. Okay? There's my tree, and they had said it was tall. They said there's a tower, and they said the tower is 44 meters from the tree. Now it's your choice. You can put the tower over here or the tower over here. It doesn't matter. I put it over here. But I know the distance between the tower and the tree is 44 meters. Okay, I'm going to draw a tower. Again, I'm not the best artist in the world. You get the idea. And this park ranger is on top of the tower. I thought I did a pretty good job getting a cute little clip art of a ranger. All right, so there's our ranger. He's up there checking things out. All right, so far so good. So now it says from the top of the tower, the angle of elevation to the top of the tree. So that tells you the park ranger is from here looking up to here. And an angle of elevation, the definition has said it's made by your line of sight and the ground. Well, the park ranger is not obviously on the ground, but we can draw the technical ground in. Okay, so we're going to draw a dotted line here. So an angle of elevation is made by that park ranger's line of sight. He's looking up at the top of the tree. So this is his line of sight. And it's made by a horizontal line. It's not obviously on the ground this time, but there's your angle of elevation. And it said it was 28 degrees. So that's where I got that from in the picture. Is everybody okay? Does that make sense? When you draw an angle of elevation, you're looking up, but then there needs to be a horizontal line that goes across. Usually it is on the ground, but because the park ranger's up here on the tower, that's where that horizontal is. And if you look, okay, what happens is from the top of the tree to this horizontal, that's got to be a right triangle. Okay? Then it said from the top of the tower, the angle of depression to the base of the tree. So now what's happening is that same ranger is looking at the bottom of the tree. So he's looking down to the base. There's his line of sight. It says the angle of depression. The angle of depression is made by the line of sight and the sky. It's not this angle here. It's not made with a vertical line. The angle of depression is made with the diagonal and the horizontal. So this is your angle of depression right there. And that was 36 degrees. So the biggest mistake you guys will make is you know to draw the line of sight, it's going to be diagonal, but you'll want to put the angle of depression here. That doesn't make any sense. The angle of depression is not made with the line of sight and a vertical line. It's always made with a horizontal. Okay? Now everybody look. If I look here, I have another right triangle. If I go from this horizontal straight down, this would meet, that would be another 90 degrees. So now if you look, I have a right triangle up here and a right triangle down here. I have two right triangles. I also know that we're not in Italy. This is not the Leaning Tower of Pisa. So this is standing up vertically tall. So I know this tower is making a right angle with the ground. So really in this picture, there are three right triangles. But if you look, we have no information inside this right triangle, so we're not probably going to use it. Okay? All right. Now the question is, how tall is the tree to the nearest meter? Well, the first thing I want y'all to notice is if you look good at the tree, look very closely. The height of the tree goes from here to here. This line segment, that side of that tree length is not in just one triangle. Now I know what you're going to say. You're going to say, yes, Miss Black, it is. Miss Black, if you go from here to here, which is the height of the tree, I agree, from here to here to here makes a triangle. But is that a right triangle? No, because these two angles don't add together to make 90. And right here, that's not 90. And here, that's not 90. Remember, in order to use trigonometry, we need a right triangle. So what I first want you to notice is to find the height of the tree. We can't find this whole length of this line segment in one shot because it's in two different right triangles. If you look closely from here to here, that is a side of this right triangle. So I'm going to label that part X. And then from here straight down to here, that is a side of this right triangle. So I'm going to label that length Y. Now remember, why do I have to label them each a different variable? Because we don't think they're the same length. If you label them both X, then you're telling me they're both the same length, and you don't know that. So what we got to do to find the height of the tree, we got to do it in two parts. We got to find the side of this right triangle. We got to find the side of that right triangle, and then we're going to add them up. Well, again, to find this length, do we have enough information to do Pythagorean theorem? Can we do a squared plus b squared equals c squared? Well, right now, if I look at this right triangle, I have no sides. If I'm looking at this right triangle, a squared plus b squared equals c squared, I have no sides. We do have a side. We have 44 meters, which is in this triangle down here. But everybody think about it. If the base of the tower to the base of the tree is 44 meters, unless this tree is crooked, from where the ranger is on top to the distance here should also be 44 meters. Do you all agree? If you realize this, if this is a right triangle and this is a right triangle, we've made a rectangle. And the lengths of the rectangle are equal. So now you do have a side inside this right triangle. And you do have a side inside this right triangle. But again, the problem is you still can't use Pythagorean theorem. You only know one side. That's why we need SOHCAHTOA, trigonometry. So how do we do trigonometry? How do we find a missing side using it? The definition said we got to put our finger on our acute angle. So if we look inside this triangle only, the acute angle is 28 degrees. We got to label two of the sides. The side we know and the side we want. Well, the side we know is 44. Well, this angle and this side are right next to each other. So this must be the adjacent side. The angle, the side we want to know is here. It is across from the 28 degrees. So this must be the opposite side. So what trig function uses opposite and adjacent? Well, let's write down our code. SOHCAHTOA. I need O and A. There it is, tangent. So we're going to write the tangent theta is opposite over adjacent. We're going to substitute in. Theta is our acute angle. It was 28 degrees. Our opposite side is x. Our adjacent side is 44. We're going to put this over 1. That just makes me feel better. We're going to cross multiply. 1 times x is x. Now watch. Don't make this boo-boo. Don't take the 44 and multiply it to 28. Because the 28 is in what units, guys? Degrees. So the 44 will go in front. So this will be 44 tangent 28 degrees. Now I need an actual number for that. So let's walk over to our calculator. All right. So I'm going to pull the pro out this time. What mode do I have to be in? Degrees. I type what I read. I type 44. I hit my tangent button, which is right there. And I put 28 degrees, and I close it. And there's my decimal. And I do not round it. I need to have it exactly, because we're not finished with this word problem. Everybody clear with that? So I'm going to write the whole decimal out right now. X equals 23.39521499, and this is in meters. Now, did we find the height of the tree? No. We only found how far it is from here to here. So now we got to do the same thing over here. Okay, let me get a different color. So now I want the height from here to here. So in this right triangle, here's my acute angle 36. This side, again, that's labeled Y is across from it, so it's the opposite side. This side that's labeled 44 is still next to 36. It's the adjacent side. So we're still going to use opposite and adjacent, so we're using the same definition, tangent. So I'm going to write that. Let me do it over here. The tangent of theta is opposite over adjacent. We're going to fill it in. What was our acute angle this time? 36 degrees. What was our opposite side this time? Y. What is our adjacent side? Still 44. We're going to cross multiply. We like our variables on the left. Y times 1 is Y. We're going to put the 44 in front of the trig function. All right, let's go to our calculator. All right, so in our calculator now we're going to type 44 tangent, and we're going to put 36 degrees. Okay? And we're going to write that whole thing down. We're not going to round. So Y is 31 and decimal point 9678712 meters. So what you found is you found the height from here to here. You found the height from here to here. But the question said to find the total height. So to get the total height, all you got to do is take these two decimal numbers and do the operation of addition. So let me go back to my calculator. So I have on the screen right now the 31, so I'm going to add to that 23. And now that I added, I can do my rounding. Do not round till the very end. So the question said to the nearest meter. Well, if we look, our value is 55.3, which would stay 55. So the height of the tree is 55 meters. And make sure you label your answer. So the whole moral of the story is there's a practical reason to know how to do trigonometry. It helps us solve real-life problems dealing with right triangles. You're going to need an acute angle. You're going to need to have one side and try to find the other side. And that's why we're going to memorize our phrase, SOHCAHTOA. If, when you're doing your assignment, there is not a picture drawn, you have to draw a picture. You can't just start setting up the trig function until you have a picture and you know which one you're going to use. Okay, we're finished with SOHCAHTOA. The next lesson is to show you how we can apply trig to other triangles that are not right. See you then.